In today's lesson, we're going to use an equation to plot the points on a graph. We're going to start with a table of values, and we'll select the value of 0 for x. And now what we're going to do is we're going to take that value of x, 0, and we're going to plug it into the equation, y equals x minus 5. Any place there is an x in that equation, we'll just substitute the value 0. So we get y equals 0 minus 5. That results in negative 5. So that gives us an ordered pair, or a point of 0, negative 5, which we can plot on our graph. Next, let's choose the value 1 for x. Now, once again, we'll substitute 1 anywhere there's an x in the equation. So we get y equals 1 minus 5, which gives us an answer of negative 4. We have a second point with the coordinates 1, negative 4, which once again we'll plot on our graph. Let's choose the number 2 for an x value. Once again, substituting 2 in for x gives us y equals 2 minus 5, which results in an answer of negative 3 and gives us an ordered pair of 2, negative 3. We'll plot this point on the graph. Notice how they're all lining up in a straight line. They're all part of the same equation. Let's put in the number 7 for a value of x. Plugging that into our equation gives us y equals 7 minus 5. The answer for y being 2. And we can plot that coordinate 7, 2 on our graph. Let's choose negative 1 for a value of x. Substitute that into the equation. Gives us y equals negative 1 minus 5, resulting in a value of negative 6 for y, giving us an ordered pair of negative 1, 6, which we can plot onto our graph. We can draw a line through all those points and gives us a nice straight line. Let's take the values from our table and let's use them to calculate the slope of this equation y equals x minus 5. We can select any two of these points. We'll choose 0, negative 5, 1, negative 4. Plug them into our formula. M equals negative 4 minus negative 5 over 1 minus 0, giving us a reduced form of 1 over 1, which can be further reduced to just 1. Let's bring back our graph showing the points that we had from our table of values. And we notice that for every movement along the x-axis, we have an equal movement along the y-axis. It's a 1-to-1 ratio, which is why we have this slope of 1. If you follow this animation, you can see that we have this nice stepwise little pattern. Let's look at a second equation. This one is y equals negative 3x plus 4. If we plug in the value of 0 into our equation, y equals negative 3 times 0 plus 4. Remember, anytime there was an x in our equation, we're substituting it with whatever we've picked for our x value. Y has an answer of 4, gives us an ordered pair of 0, 4, which we can plot onto our graph. Let's use an x value of 1, plug it into our equation. Y equals negative 3 times 1 plus 4 gives us a value of negative 1 for y. we now have an ordered pair of 1, 1. I have made a mistake here. I've put -1 here. That should actually be a 1. If we take the value of 1 for x, -3 times 1 gives us -3, plus 4 gives us an answer of 1, positive 1. This should read as positive 1. Okay. Here we've got the right values. Plug that into the equation, then I'll plot it onto the graph. Let's take the value of 2 for x, substitute it into our equation. -3 times 2 plus 4 gives us an answer of -2 for y. We have a coordinate, or pair of coordinates of 2, -2. We'll plot this onto our graph. We'll use the value 3. Substitute x for 3. Gives us an answer of -5. We have the coordinate pair of 3, -5. We'll plot that onto our graph. Let's go back up to the top of our table where we have -1 for x. Plug that into our equation. Gives us an answer of 7 for y. So our coordinate pair is -1, 7, which we will plot onto our graph. Now we could draw a line through each of those points. Makes for a nice steady slope. What that slope is? Well, let's calculate that. We'll take the ordered pairs from our table, rewrite them over here, and once again we'll select just 2 pairs. And we'll take 0, 4 and 1, 1, plug that into our slope formula. Slope equals 1 minus 4 over 1 minus 0, giving us -3 over 1, which reduces to just -3. Bring these plotted points back onto our graph, draw a line through them, and note that for every 1 unit across the x-axis, we go down 3 units along the y-axis, which is why we have this -3 slope. It's sloping downwards to the right. And once again, our animation can show this pattern: 1 to the right, 3 down, 1 to the right, 3 down. Now let's take these 2 equations and their graphs, and let's put them on the same Cartesian plane. I want to notice a few patterns about this. We established that the slope for y equals x minus 5 was 1. This equation has a slope of 1. Look at the x coefficient of this particular slope. The x coefficient of this equation is 1. The slope is also 1. This is no coincidence. Let's take a look at our equation y equals -3x plus 4. Earlier on, we established that the slope for this equation was -3. And once again, look at the x coefficient of this equation. It's -3. Again, no coincidence. In fact, we can state that as a bit of a rule. In this form, the x coefficient indicates what the slope is. For the equation y equals -3x plus 4, our slope is -3. For the equation y equals x minus 5, our slope is 1. Now look at the b values for each of these equations. For the equation y equals negative 3x plus 4, our b value is 4. Take a look at the graph. Note how the graph crosses the y-intercept at the value of 4. Our b value of the equation is 4. The graph crosses the y-axis or at 4, or we could say the y-intercept is 4. Take a look at the other equation, y equals x minus 5. The value of b in this equation is negative 5. And once again, we see that the graph crosses the y-axis at negative 5. So the b value is the same as the y-intercept. The x coefficient is the same as the slope. And this pattern will be of great use in later lessons.